This is the 66th lecture in the FOA Lecture series on fiber optics. In this lecture, we're going to talk about fiber to the home installation and test. It's part of a four-part series of updates on fiber to the home that cover fiber to the home architectures, passive optical networks, FTTH design, and this one on installation and test. A short lecture like this is not going to cover the details of installation and testing of fiber to home networks. We have plenty of other material in the FOA website on FiberU and the FOA guide that covers installation and construction of fiber optic networks. Fiber to the home installation really falls into three categories. The backbone, or the feeder and distribution network, as it's generally called in fiber to the home, is standard outside plant construction and installation. The drop to the home is simplified outside plant construction, often involving pre-terminated or prefabricated components that are installed by a technician who may not have the high-level skills of a fiber optic splicer. The customer premises is often a tech who not only knows how to run cables inside the home and satisfy the needs of the homeowner to make it look neat and workmanlike, but also knows how to connect up televisions, telephones, and computers and make them work on the new fiber to the home service. Another way to look at it is with this block diagram. Within the central office, there's a certain amount of customer premises cabling to connect up the electronics. But techs in the central office will also be connecting up all that equipment and making it work throughout the network. In the outside plant, the techs who install the feeder and distribution part of the network are typically going to be skilled fiber optic outside plant techs who know how to install cable, splice and terminate cable, and who are used to dealing with things like splice closures and fiber distribution hubs. The drop to the home is generally another technician who may install the cable drop to the home and then go into the home and work in the customer premises, connecting up the devices that the customer wants connected to their new fiber to the home service. The outside plant techs who install the feeder and distribution part of the network will use their standard fiber optic installation skills for pulling or placing cable, both aerial and underground, mounting hardware, doing splicing and termination, and then doing the testing of the cable plant. They may have to do some equipment test according to vendor requirements, and they may need to do some training for people who are involved in operating and servicing the network. These are your CFOTs, who generally work in an outside plant environment. Fiber to the home can use standard construction practices like lashing cables to messengers for aerial installation, or digging and trenching for underground conduit installation, or pulling cables into underground conduit that's all in place. But there's also, in the cities, a lot of new techniques being used, like micro-trenching, where a groove is cut into the road, micro-ducts are laid in, and micro-cables blown into the micro-ducts. It's good if you're an outside plant construction technician to make sure you're familiar with new techniques like micro-trenching, because they are being widely used in urban and suburban areas for fiber to the home installation. The head end or central office equipment for fiber to the home is not much different than a telco system that we've all been familiar with for many years. Here is a system, for example, for a passive optical network serving about 5,000 subscribers. On the right is the optical line terminal with ports going out on the outside plant cable. In the middle is a patch panel where the outside plant cable is connected to the patch cords that go into the OLT. And in the background you can see the router that connects it as the OLT to the internet on an incoming fiber optic cable. The installation of this equipment is similar to any other kind of communications equipment and should be familiar to the techs who've been provisioning central offices for years. What's new in fiber to the home is the use of splitters in the network. In an urban area, those splitters are often placed in large pedestals, cabinets, on the street, where an incoming feeder cable is connected to a large patch panel and includes the splitters that are used to split out to the individual users. So we have a patch panel, splitters, incoming cables, outgoing cables. It's a different kind of hardware, but should be familiar to any kind of tech who's serviced fiber optic equipment in the outside plant in the past. The techs who are doing splicing may see some new types of hardware. The dome closure on the left has a cable coming in and going out with mid-span access to drop fibers to the smaller cables you see below, which are drop cables or distribution cables going to subscribers for fiber to the home. The hub on the right is actually terminating some fibers in connectors, and the connectors are on the back side of outside plant weather-sealed terminals. So a pre-fabricated cable with a weatherproof connector is simply plugged into this hub to do drop cables to the customer. Here's another type of closure that's become quite popular for fiber to the home. We've got the cables coming in and going out, and a mid-span drop of one of the tubes where the fibers are spliced to pigtails. The pigtails are terminated in APC-SC connectors into a miniature patch panel. The drop cables going to the customers are brought into the closure, and those fibers are terminated with mating SC connectors. So each drop cable, which will have its own individual port on the closure, is terminated in a connector. So the mating of the fibers here is not done with splices, it's done with connectors. This gives you the ability to add users at any time without having to go into splice trays and find individual fibers. And it allows you to add and move current subscribers. So this has become quite popular for drop cables and fiber to the home networks. The tech working with this type of closure needs to understand mid-span access, and they need to understand splicing because they're going to be splicing on pigtails, and they may need to know how to put splice-on connectors on fibers. So all of those topics are covered in the FOA guide and in FiberU as part of free online courses. At the location of the subscriber, the tech may find lots of different options depending on the hardware chosen for the network. In the right, you can see a combination demarcation box where a fiber is terminated into the closure and then connected up to the optical network terminal, which is in the box. From the ONT, the tech has to run a coaxial cable for television service, if that's required, a twisted pair cable for Ethernet internet connection, and perhaps even twisted pair phone lines for phone service. Other types of systems may only terminate the bare fiber on the outside, and the tech will run a fiber into the home where they will connect up the ONT, which is often a box that looks like a cable modem or a DSL modem, somewhere inside the subscriber's home. That requires running a fiber optic cable from the outside into the home and to the location where the ONT is going to be situated. Some home builders have built boxes into the home that look like terminal boxes in a commercial application. And it has room for the cable modem or fiber to the home modem, and then connects cables to all parts of the house for the internet and cable TV and phone service. That's not very common these days, and mostly what you'll find is there will be a fiber to the home ONT somewhere in the house, and it will be connected to a Wi-Fi router. Since most people use mobile devices or even televisions that connect up to the internet over Wi-Fi. The tech who does the installation in the home on a fiber to the home network is probably going to have familiarity with fiber optics, so they know how to handle cables and typically might be able to do some termination. But they're going to also have to have skills in how to connect up all these devices that the customer expects to work over their new fiber to the home network. So they're going to have to know how to deal with UTP cable, Wi-Fi. They might have to deal with coaxial cable and a system that puts the internet over coaxial cable called MoCA. They're going to have to be able to connect up televisions, TVs, and phones and make them work. They may even be asked to help hook up home automation devices. The techs doing installations of fiber to the home in multi-dwelling units have to have all those skills that the customer premises FTTH tech needs. Plus, they're going to have to be skillful at running cables inside buildings, many of which are buildings that are never designed for installing additional cables, and certainly not fiber optic cables. Fortunately, there's lots of new types of components of fiber optic cables that are very small, use bend-insensitive fiber, and are relatively easy to install in old buildings. So it depends on the designer to choose the right components to make the technician's job easier. And the technician must be sure they're trained in the use of these particular components. There are additional FOA resources that techs can use to learn about installation and fiber to the home installation. We particularly recommend the sections on OSP construction and OSP installation that are available on both the FOA guide and on FiberU. FOA also has an outside plant textbook that you may find useful in your work as a reference book. Fiber to the home, particularly passive optical networks, present some new challenges for fiber optic testing techs. It's similar to testing outside plant cables because you're going to measure insertion loss, and you might even be using an OTDR. But the splitters and wavelength division multiplexing used in passive optical networks adds complexity as well as loss to the network, both of which need to be quantified. The testing is different whether during installation or once online and live, because the network can't be shut down because there are, for example, 32 users sometimes on the output of a single splitter. So the testing must be done without disturbing everybody else on the network. Fortunately, there's a lot of intelligence in both the OLTs and the ONTs, which allows troubleshooting. And the tech who does this kind of troubleshooting will probably be trained by the equipment manufacturer and can do the complicated troubleshooting. The installation tech, probably not so much. The tests that will be done will be tests to measure end-to-end insertion loss during installation and before operation, with tests done at both 1310 and 1490 nanometers, and maybe at 1550 nanometers. They will require insertion loss tests and reflectance tests. Reflectance is important because these are short networks typically, and reflectance can cause more problems in short networks because of the fact that the reflected light is not attenuated over long lengths as it is in long-distance networks. So reflectance is a bigger issue. OTDR testing, if it's done, requires special OTDRs generally because the lengths are short, and OTDRs are really primarily designed for long-haul networks. There's also some quirks in what happens when you use an OTDR on a network with a splitter, and we'll look at that in a minute. When you test the loss of a link in a fiber-to-the-home network using a passive optical network architecture, it's a little bit different than just a simple fiber point-to-point link, because you have connectors on each end, one for the OLT and one for the home, and in between you're likely to have fiber splices, just like you would in any other network, but you're also likely to have some connectors, and of course you're likely to have the splitter. So when you measure loss in a PON type architecture, you have some new components that are going to be included when you make your test. And they're of course included in the measurement of the loss and comparison to the loss budget calculation made during the design phase. I expect you'll be surprised the first time you use an OTDR on a passive optical network and look at the signature that you get going through a splitter. Because if you're shooting with the OTDR down the single fiber input to a splitter, it will go through the splitter and you'll see the loss of the splitter, but then you will be seeing the backscatter signal summed from all the fibers on the far side of the splitter. You will see a peak at the end of each of them, indicating their different lengths, but it is impossible for that segment of the test to look at each of the fibers individually. You're looking at the summation of, in this case, 4 fibers. Here's what we mean. Here's an example of an OTDR trace through a 1x16 coupler with various lengths of cable attached. So what you see is the loss of the coupler, where the arrow is pointing, and each of the reflectance peaks over the next distance shown is the end of a different cable. Very difficult to get a lot of useful information when you're looking at a trace like this. So generally speaking, OTDRs are used not to go downstream like this, but to go upstream from the subscriber toward the head end. Upstream trace on an OTDR makes much more sense, because what you will see is you will see the trace from the fiber that you're connected to, and you won't see the other fibers on your side of the splitter. You will, however, see the fiber on the far side of the splitter, and you will see the loss of the coupler and the end of the fiber on that side. This one is a little bit easier to interpret, and it's why generally you use OTDRs upstream on passive optical networks and test each fiber separately from the subscriber up toward the central office or head end. The trace that we showed you previously with the 16 different fibers shot not downstream but upstream from one of those 16 fibers. You can see the short length of cable going into the coupler, the large loss in the coupler, and then what looks like a relatively normal OTDR trace. So if you're trying to use an OTDR on a passive optical network, it's much easier to acquire and interpret data shooting upstream from the subscriber. FTTH techs may also be involved in testing the network equipment. Will the equipment transmit and receive properly? And troubleshooting or testing is very simple. It's a matter of optical power, like every other network. Is the transmitter output within spec? Is the receiver input within spec? And then, of course, if it is, you plug the system in and see if it works. Fortunately, it's pretty simple because of all the diagnostics that the manufacturers have built into the equipment itself. In this video, we're only focusing on the specific topics related to fiber to the home and particularly to passive optical networks. If you're interested in learning more about various aspects of fiber optic installation and test, there's plenty of pages on the FOA reference guide on the FOA website and self-study programs, all free, on FiberU on the FiberU website. We're the Fiber Optic Association, the International Professional Association of Fiber Optics, and the internationally recognized certifying body for fiber optic technicians. If you want to learn more about fiber optics, fiber to the home, or almost any other application of fiber optics, go to the FOA website, foa.org, and the FOA guide has 1,000 pages of technical information that you can use for reference. If you like to take online courses, FiberU has more than 24 free online courses that you can use to learn about almost any topic in fiber optics.